Today, we are diving deep into a document that could, quite literally, save your life. It's India's National Building Code, and it's basically a rulebook that's been written from the hard, painful lessons learned from fire.
So let me ask you something. Have you ever been, say, on the 20th floor of a tall building and had that little thought flicker through your mind, what happens if the fire alarm goes off right now? It's a pretty common fear, right? But what is it that actually protects you way up there? Are you just counting on the fire department to get there in time? Or is there some kind of hidden safety system already built in? Well, the answer is right here. It's in the National Building Code of India, specifically Part 4, which is all about fire and life safety. Now, this isn't just some boring, dense book of regulations. Think of it more like a comprehensive strategy, a blueprint that's designed to give every single person in that building a fighting chance, long before the first siren is ever heard. Okay, so here's how we're going to break it all down. First, we'll look at the why behind all these rules. Then, we'll get into how buildings are actually designed to stop fires before they even start. After that, we'll trace the escape routes that are planned out for you. Then, we'll uncover how the building itself fights back. And finally, we'll tie it all together and see what it means for you in your day-to-day life. All right, Section 1, a rule book written in fire. The big idea here is that this isn't just about making rules for the sake of it. No, the fundamental goal of this entire code is life safety. It's all about minimizing the danger to people from fire, from smoke, and even from the panic that can set in. And that brings us right to our second section, the blueprint for prevention. Because, let's be real, the absolute best way to survive a fire is to stop it from getting out of control in the first place. This is where the building's actual design becomes its first line of defense. You see, the code is smart. It knows that a one-size-fits-all solution just won't work. So its very first job is to figure out the risk. And it does that by classifying every single building not based on how big it is, but on its purpose. You know, what people are actually doing inside. They use something called occupancy groups, and it's actually a really intuitive system. I mean, it just makes sense, right? A Group A residential building is going to have a totally different risk level than a Group G industrial plant or a Group C hospital, where people might not be able to evacuate on their own. The code sets different safety standards for each one. And this planning goes way beyond just a single building. The code actually creates fire zones across an entire city. So Zone 1 might be for lower risk areas with homes and schools, while Zone 3 is set aside for high hazard industries. It's a simple way to make sure you don't end up with a chemical factory right next door to an apartment complex. So once the risk is defined, the code tells architects how strong the building needs to be using 4 types of construction. At the very top, you have Type 1. This is the most robust, where the main parts of the building have to resist fire for up to 4 hours. 4! And at the other end, you have Type 4, which might only need to hold up for 1 hour. The higher the risk, the tougher the construction has to be. And here's where you can really see the difference it makes in the real world. Let's look at an interior bearing wall. You know, one of the walls holding up the floors. In a Type 1 building, that wall has to stand strong for 240 minutes. But in a Type 4 building, just 60 minutes. That's a 3-hour difference in structural integrity. That's 3 extra hours for people to get out and for firefighters to get in. It's huge. You know, the code itself says it best, right in the introduction. The goal isn't some impossible, perfect level of safety. It's about providing a degree of safety that is, and I quote, reasonably achievable. It's a practical, engineering-based approach to saving lives. Okay, let's move on to our third section, the path to safety. Because look, even with the best prevention in the world, fires can still happen. And when they do, your escape route has already been meticulously planned for you, right from the architect's very first sketch. The official term for this is the means of egress. And it's not just the exit door. It's defined as a continuous and, this is the most important part, unobstructed path from literally any point inside that building all the way out to a public place, like the street. It is your entire escape journey from start to finish. And this is the actual diagram from the code itself, showing how they see this journey. It might look pretty simple, but it breaks down your escape into 3 very distinct, highly regulated parts. This ensures that every single step you take is designed to be as safe as possible, even under pressure. So let's trace that path together. It all starts with the exit access. That's the hallway or path that leads you from where you are to an exit. Then you reach the exit itself. This is usually a fire-protected stairwell or a special doorway. And finally, you have the exit discharge. That's the final leg of the journey that takes you from the building's door safely out into the open. Now for Section 4, Fighting Back Against Fire. So far, we've talked about preventing a fire and escaping a fire. Now, let's look at how the building itself literally goes on the offensive with active systems that are designed to attack the flames directly. These are the things you've probably seen before. Automatic sprinklers in the ceiling, smoke alarms, those glowing emergency exit signs. But the code also requires things like wet risers. These are basically a network of pipes, always filled with pressurized water, running up through the building. It means firefighters can immediately hook up their hoses on any floor and get water instantly, instead of wasting critical time dragging heavy hoses all the way up from the street. But one of the most critical active systems is one you've probably never even noticed, the firefighting shaft. The best way to think of it is as a fortified express lane just for emergency crews. It's a dedicated, fireproofed enclosure with a staircase, a small lobby, and a special elevator called a fireman's lift, giving them a safe and super fast way to get to any floor. And you can see in this layout from the code how it all fits together. The lobby, the lift, the stairs, they're all in one highly protected box. This whole area becomes a secure base of operations for firefighters, letting them attack the fire from a position of relative safety. And the features here are seriously impressive. The walls have to have at least a 2-hour fire resistance rating, the lift is only for firefighters and their gear, and it has its own built-in water supply right there in the lobby. It's basically a self-contained firefighting command center built right into the core of the building. So, all of this brings us to our final section, the code in your life. After all these technical details, why does any of this really matter to you on a normal day, whether you're at the office, the mall, or just at home in your apartment? Well, it matters because this isn't just a random list of rules. The code creates this incredible, integrated, 3-layered defense system. You have passive prevention from the building's construction that buys you time. You have the life safety plan that gives you a clear path out. And you have the active protection systems that actually fight the fire. All 3 of these layers work together for one single purpose: to keep you safe. So the next time you walk into a hotel, a movie theater, or an office building, just take a second. Look around. Can you spot the exit signs? The sprinklers? Can you mentally trace your path to safety? The code has already written a safety plan into the very walls around you. And knowing that it's there is the first step to being able to use it if you ever need to.